graph of the function f is shown above. Which of the following statements is false?
Okay, which one is false? What'd y'all get actually?
C.
C, that is correct, and let's see why that is the case. As limit x approach the 4 from the left and the right, what is happening? There's a jump, so it does not exist. The rest of them do exist. So do I need to go through that part? We're good on that? Okay? For number 39. Presley, go ahead and read that one.
The graph of f is shown above. Which following statement is true?
Okay? So for this one, must be true. Which one is true then?
D.
D it is. Let's talk about why that is. So as we approach 1, from the left it's going to another limit, and then from the right is 2 different limits. So they do exist. From the left, they do exist also from the right, but they're not equal. Okay, let's go on to number 40. Will, let's read.
Let f be the piecewise function defined above. The value of limit x to 2 positive f of x is.
So it says as we get to 2 from the right side. So when something is less than, it is on the left. When something is equal to, it is at that point. When something is greater than, it is to the right. And so which equation are we going to use for the bottom one? So we're going to plug in the 2. So we have 2 all squared minus 4 times 2. That's a squared. Plus 8. And that's going to give us 4 minus 8 plus 8. And we have a 0 pair. So it's got to be C. Next page. Okay, on the next one, it says to find the derivative. What rule are we using on 41? Product rule. And just to make it look product rule, I'm going to write this as in its own set of parentheses. So let's recall. We derived the first one, which is 2x. I keep the second one. And then what operation? Plus. So I keep the first one. And the derivative of e to the x is e to the x times the derivative of the power, in this case is simply 1, that I don't need to write. And then between these two, there must be a GCF. They both have x's, and they both have e to the x. So I have remaining 2 plus what? Plus x. Which option is that? C it is. All right, the next piece. So when it's approaching a number, we have to plug it in. So when I plug it in, if I plug in 2 into this one, we have f of 2 minus f of 2, that's a 0. On the bottom, when I plug in the 2, is 2 minus 2, that is 0. So what rule are we going to use?
Do more.
It is do more, or L'Hopital's rule. And that states, simply derive the top and the bottom separately. And just because I'm thinking ahead, I want you to write something out. If I have f of 2, and they gave us what the f of x is, it's natural log of 2. Is natural log of 2 a variable or some random number? Is it some random number? And I'm saying this for a reason. So when I derive the bottom, we have the limit as x approaches the 2. So deriving f of 2 is going to give us some random number, so it's going to be 0, minus f prime of x. On the bottom, when I derive x, I simply get 1. Are we good on that? So let's talk about f prime of x. F prime of x, deriving natural log of x is 1 over what? 1 over x, very good. So then, I'm going to go ahead and plug in the 2. So this is not needed. When I plug in the 2, I get, I did that minus sign, silly me. Negative f prime of 2 over 1, meaning I need to plug in 2 right here. So that's going to give us negative 1 over 2 over 1, although that over 1 is understood. So our answer must be what? B it is. Okay, did anyone get up to 43 on their own? Kind of, okay? So on 43, before reading anything about this, let's see if the function is continuous. So let's kind of recall. If the function is continuous and I plug in the 5, they must both approach the same number, correct? So let's plug it in. Plugging in 5 here, which I really can't. It's going to be 5 comma 2. And for my second one, when I plug in the 5, that's going to give us 5 comma. So 5 times 2 is how many? 10 minus 4? So we have a big problem. Is it continuous?
No.
So there's a big jump. So when there's a jump, it is not continuous. Now read through the choices A, B, and C, and D on your own and tell me which one is going to suit this the most. A it is. Very good. Okay, let's go on to number 44. Okay, on number 44, Hannah, let's read.
Let g be a function such as limit as x approaches 2, g of x equals g of 2, and limit as x approaches 2 on the right, g prime of x does not equal limit as x approaches 2 on the left, g prime of x. Which of the following could be the graph of g?
Okay, I want to first talk about the first condition. Isn't that the limit definition? When the limit is approaching the same number and the point exists, that means we have a continuous function. Let's all write out continuous. So then, when I analyze all of my answer choices, there's 2 that are not continuous. What are they? A and D. So then, let's talk about the second condition. My second condition says primes are slopes. Derivative is a slope function, correct? So it's saying on my left and on my right, we have different slopes. Which one has that? B. So here my slope is positive. Here my slope is negative. And then it is a continuous function. It's got to be B. Okay, I want to talk about why it's not C. Because you might say, well, do we have the same slope? So if you look at this slope over here and something ever so slightly closer, could it be maybe possibly parallel? Not only that, there's one more item. When I get to that point right there, at some point we're going to get to a slope of 0 from the left and the right. Okay? So then let's move on to number 45, our last one. Jason, let's read.
The graph of function f consisting of the 2 line segments is shown in the figure above. Let g be the function given by g of x equals 2x plus 1, and h be the function given by h of x is f of g of x.
So are we looking at, sorry, you can finish.
What is the value of h prime of 1?
Sorry, I'm rushing you. So we have our chain rule, okay, function within a function. So let's go ahead and write out h prime of x is equal to, we derive the outside, and we keep the inside as it is, and then we multiply by the what? Derivative of the inside. And now let's plug in the 1. So we have h of 1, and then plug it all the way in. So let's see what I need at the moment. Can I find g of 1? So when I plug in g of 1 into this one right here, it is 2 times the 1 plus the 1. So what is g of 1? So this is going to give me f prime of 3. Now can we also find g prime of 1? Let's first derive. G prime of x is 2. So no matter what I plug in, it's going to be 2 no matter what. So we know that value is 2. So then our last part is f prime of 3. So I gave you nothing with the equation in regards to the f. But what do I know about the graph? The graph of the function f is given. So f prime of 3 tells me the following. It's saying, what is my rise over run at 3? So here's my 3 right here. So what's my rise over run of this line? Should be some negative answer. -2, very good. So we have -2 times 2, which is how many? -4. Answer choice what? Boom.